Hi guys, welcome to part 4, I believe, of this series of videos on trying to refactor our modeling of Visual Studio components. I've lowered the volume yet again. Hopefully the sound this time will come slightly more acceptable levels. Let's clock our time here. So where we left off last time is that we were reading all the properties related to the new meta element, which we called ABC for now. If you remember, we're going to ignore the name, and that's due to our new shiny simple name internal property that we're going to use to determine the name of this modeling element when it gets projected to the extraction space, to generation space even. So the idea now is going to be that we need to ensure that across the entire pipeline, and now you'll see this is a bit of a manual process really, but across the entire pipeline inside of Dogen we need to make sure that we're propagating, I guess, the type across as we go along. The easiest thing to do is to just take any meta type that we've got, for which we've done this already, such as, say for example, type registrar is actually fairly complicated type because it's got its own transform and we need to do things to it. See if we got something simple. Well, maybe type registrar is the easiest one, to be honest, because pretty much everything else has also got transforms. So let's do a quick grep for type registrar across the boards. I don't know why, but my grep always goes down there. Something else needs to be fixed in this Emacs. But here we are. So we have type registrar everywhere. Now a few of these things are not that relevant, so we don't care about type registrar IO. We do care about the method in factory. Care about element visitor. Don't particularly care about the element repository. Don't care about that. We do care about the element. Oh, actually, sorry, don't care about element visitor. It's automatically generated. We do care about transversal, and I think from here on we care about pretty much everything that's going to come through. Let's have a look. So the transversal, we definitely need to add our new type to it. We don't care about IO. Don't care about repository. Don't care about object. We do care about the meta naming transform. Okay, so let's just start with the transversal first. Again, as with previous videos, we're going to try to shorten or narrow down the work to about an hour. And after that, we'll just call it a day for the video, just so they don't become too long. So as you can see here, we have a whole lot of code here that really should be code generated, which A, we haven't got time for yet, and B, we haven't quite figured out how to code generate it. And what we need to do is to make sure that this code, so these are the build elements, I know the build elements we want, the components. So this code basically enables us to iterate through every single element across the model without having to worry about the individual collections that we've got. Now this is not the most brilliant design, as you probably figured out already, but it's the design we currently have and it's been used for many things, so we haven't had the time to sit down and think how best to do this. So we're just going to keep the pattern as is. At some point in the future, when we finish with all these refactorings, we'll revisit this and do a nice tidy up. For now it kind of works well enough, I guess. What we should do as well, actually, while we're here, let's just hop over to number 2, and let's just start writing down here. So how to add new meta model elements. So step 1 is create a namespace and type in assets model. This is the first thing we did. Step number 2 is add enumerations for the meta type in assets. This is one of the things we wanted to do, so that next time we need to do one of these guys here. In static stereotypes. And then number 3, we'd like to there's like a stereotype registration helper, presumably around here somewhere. Quite sure it was here. Can't quite find it, so stereo. Sure it's even open. Stereotypes helper, here we are. Not sure why that didn't come up. Should have been here, stereotypes helper. Finding elements in Dia is actually not an easy thing to do. There is a search, but I never managed to get it working. And visually, it's, maybe my eyesight's going, I guess, but it's not quite as easy as you thought it would be. So stereotypes helper is definitely here. I just can't see it. Annoyingly. But it doesn't really matter because we got it here. If you just go up to, let me just get rid of split 20. Add processing new stereotype to setup helper in assets. And 4, add processing. Meta type in adapter in engine, and also in our transform, which is this guy here. Okay. So at that point we more or less read everything we need to read, so we can then say add any meta type specific transforms to assets. We didn't have to do this. And then 6 adds meta type to. Now we are where we are at the moment. So this is the traversal. Okay, and then it's traversal. We just need to. You see how carefully I'm adding this by copying and pasting the exact lines from above. We've tried to do this faster last time, and we figured out that there's slight differences between these, for good reasons of course, but they're sufficient to then cause very hard to troubleshoot problems. So it makes sense to do this slowly. Make sure we don't do anything silly, or not too silly anyway. Okay. So you can see it's easy to do silly things here. Okay, getting some noises downstairs again. Okay, looks like we had it everywhere. So that's types registrar, and that looks good. So now if you keep going and look for the next place where we need to add some entries in. Don't need to worry about any of this generated code. Right, now we enter possible places where we need to add something. So meta-naming transform. Pretty sure we do. And Emacs quite helpfully gives me a buffer miles away from where we are. Right, so let's just go back to our notes. To be honest, we're just gonna add the names of the transforms because we know what they are. What needs to be done, I guess. So we must have some kind of factory here. And just need to make sure we add an entry to the factory. Right, so presumably, of course, as you can imagine, I mean, you probably by now have figured out that all of this should really be code generated. I mean, whenever you're doing tasks like this is almost like the entire purpose of Dogen, really. Whenever you're doing lots of tasks like this, where it seems like you're literally just doing a meta exercise somewhere in the code base. You're literally going for every type, please do this, blah blah blah. You are really in the domain of Dogen. This is really where we should really, at this point in time, should be thinking of how do I create some method data structure that somehow automates this for me. However, as you can imagine, this is a bit of a recursive problem. If we spend, every time we find something that's cyclical, we try to automate it, we end up never having time to actually do the real work of sorting out Dogen. Probably should be past 80 lines, but it isn't. So we are in builds to components. So one has to somehow find a balance between these two activities and somehow get things working without jeopardizing the entire project, because it's important to get something working. So I assume that we're going to have some includes here. As you probably are aware, we need to do the hackery run includes. I'm hoping that with the near release of Clang, I'm dying to upgrade to. In fact, let's have a quick look to see where we are. Clang 10. So we still have Clang 11 as a released notes, but oh no, okay. So this makes me think that perhaps Clang 10 has been released. That being the case, let's not make this too much of a wild goose chase, but hard to find. Where is the latest compiler version? You'd have thought it would be quite trivial, wouldn't you? What's this? Clang release notes, MASD. Clang tank in progress, okay. So it looks like Clang tank's not yet out. Presumably there's just 0 releases as well. Well, we're all quite eagerly waiting for the release of Clang 10. So, still on preview. That's going to give us a nice, new, shiny Clang D, hopefully fixing a whole lot of problems, including this problem. It seems to annoy so much. I must say that every release Clang D is improved quite dramatically, really. Interesting that these types here. Oh yeah. About to say we don't seem to be mentioning their namespaces. And as you can see, this is exactly the kind of mind-bogglingly boring kind of work that one has to do if you don't have a code generator. However, such is life. One has to bootstrap the code generator. It's very important. It would be nice if Emacs was helpful. No, okay, oh, there you go, finally. So this is more focused on the type registrar transform. We don't particularly care about type registrar transform. Merge transform we do care about, because if we do not merge, we will lose our new type. Ideal. Don't really like the fact that we're going past the red lines here, but code would look even uglier, I guess, if we didn't. So that's probably why we accepted it. This is another thing that needs to be done for this code base. We really need Clang format. Again, we haven't had time to do that. I think that's one of the sort of the most important things as a open source project manager or maintainer is how do you determine what needs to be done and what's the right next task. That kind of in some ways is quite an important and decisive aspect of the maintainership, because if you're not careful you get lost in sort of a permanent refactoring exercise and you never get any work done. But at the same time, no one is here to really board daily, so you need the work to be interesting as well, and to make it interesting you need to tackle some of these problems. Right, okay, so I think we probably got everywhere. We've done everything now. Now the rest is the left is going to be format related. So what we're going to do now is, if everything goes according to plan, just compile this, and if nothing breaks on all tests, so okay, right, that's not what we wanted to do. Compile the wrong thing. Okay, that's much better. Right, so elements to reversal first. I suspect the problem here is that we forgot to include build. Let's be careful here. Components. Excuse me. Right, let's try again. I'm sure we have similar problems in other places. But there's generally we're trying to do is to try to grab all the things in assets that are needed in order to process this type along the pipeline and taking us to generation. Right, okay, so that's not too bad. So first let's just do run all tests. Okay, a couple of breaks. Name must have a non-empty ID. Most interesting. So our post-assembly validator is not very happy with the name of our model, of our new type. It's quite interesting actually, because you would have thought that the name would be ABC. Seems as if Well, let's first have a quick look at where this validation is happening. Post-assembly validator, yeah. Line 84. I know it's quite annoying that we don't really get resolution. Should be able to just click on it and take you there. And it should have, but for whatever reason that doesn't seem to work. 89. So we seem to think that the qualified name of... okay, I think I know what's going on here. Seems to be decomposition, I believe. So... yes, here we are. So we have a decomposer here. Let's have a quick look at what the decomposer is doing. I vaguely remember... here we are. So... interesting enough, we haven't added any of the new types to this decomposer. Presumably we don't need to add all types, because otherwise this would be failing by now. So I think, well, one thing we need to do is to get rid of these. Let's put a note here. Remove types that are not special from decomposer to avoid confusion. Okay, so I think we need to do that at some point, but more importantly, as you can see, there's no type registrar here. There's nothing. There's none of the new meta types, so I don't think that's the problem per se. So if that's not the problem, what is the problem, I guess? What we'll do is, for good measure, let's just hop over to the reference model, and then let's just generate the model with logging, because what that enables us to do is, I mean, I could of course do exactly the same thing for tests, but it will take me a bit longer, whereas if I just regenerate the model with full-blown code generator, I can literally just hop over to the log file and away we go. So, according to this, that's where the error is coming from, and so here we are. So, it is as if the name, so this is why we have all these sanity checks, exactly why we have silly mistakes, so as if the name that we're being supplied with is completely blank. That is peculiar. Post-assembly validator. See, this is exactly the point where the relational model now will be quite helpful, because it seems that at some point inside of the pipeline we are trashing the name. Now, as we've seen before, well, let's just double check. I was just going to say, as we've seen before, the name looked fine. Perhaps things have changed since then. Let's just get ourselves to the directory. Tracing. Right, so we think the name that's being outputted out of the generator looked vaguely sensible. No. And Emacs is choosing the wrong buffer. So if I look at this, and if I just quickly have a look at what we think the name is, yeah, as you can see here, we have a simple name we seem to have the model module set, internal modules are empty, and things set to true. So that looks very good. It looks like what's coming out of the adapter is perfect. So I'm not going to complain too much about that. So now we have a whole load of asset transforms. Sadly, these are going to generate a lot of data. Let's go have a quick look at what we think is the output of the merge. Now this is not going to be a small model. That's not too bad. Similarly, we should be at the end of this, and we should be able to find the name. Again, the name looks more or less similar. Looks very nice, actually. So, it seems to me that up to the assembly, everything was looking fine. The name was perfectly fine. It all looks very good to me. However, when we enter the post-assembly chain, at some point around here, something bad happened. So what we'll do is we'll look at the very last transform of this chain and see what the name looks like. Well, surely by now you probably already realized this is exactly where I write the relational model is, because as you can see this is a bit tedious to do manually. And yet again that looks perfectly fine. Oh, I wonder if the problem is not within attribute. Okay, let's just rewind a little bit. Let's have a look at the decomposer line 89 again more carefully. Actually not the decomposer but the validator. And I think we may be validating an attribute. Okay, let's see what the decomposer would do. No, actually it's not going to care about attributes, I don't think. Which is in itself an interesting thing, really, because it probably should validate the attributes. And we're not actually doing that, but that's fine. So I suspect not clear to me what we are validating here. So what is this string? So we are doing a validate names. Where are these names coming from? Is this a meta name or a real name? Meta name, okay. Slight problem. Yes, okay. It seems to me that the problem is with the meta names transform. And that would mean we already tried to do that, but we seem to have failed. Yes, okay, correct, okay. So the meta names transform. Should have been meta name transform. Meta naming transform, classic name. But I think the problem, of course, and here we are. We started this exercise, and this is how it is easy to make a mistake. We started the exercise, we never completed it, and what we meant to do here is now you can see why we have so many checks, and we made a mistake. Include. Hopefully it will sort itself out. Clearly we are waiting for Clang 10 on this. Right, in here we need to just make sure that we just go build. bit of luck. Okay, you just have to be very careful that you're running the right thing. Right, so the objective of this exercise in this video, okay, I mean you can see it's all green. I think that, not exactly why, but we seem to exactly, so we don't seem to link everything, well just the CLI I guess. Nonetheless, let's go back to where we were. Right here, and now if we generate every single model with a new, that worked really well. Okay, cool. So one last thing we need to do then is we need to just go back to our tests here. And what we need to do is to say, if I go to generation, the very first thing that I get on the generation chain effects. Around here there's going to be a assets to generation model, which is this chap here. If I JQ that, now it's going to be a big old model. 2 megabytes, not that big I guess. My point is though that I expect to see, right, this is the input, so I don't care about the input, I care about the output. So if I JQ the output, now the output is going to be a little bit harder to parse because it's no longer got the nice order that we expect. So elements could be anywhere around here. So what we're going to do instead is we're just literally going to look for ABC. And as you can see, ABC is nowhere to be seen. This is, well, good and bad. It means that we failed. Let's look for Visual Studio components. And then again, we can't see it here either. So what this tells us is that when we were adapting the model into generation, we forgot to copy it across. Again, this is clearly an architectural error. These things should just happen automatically, but you just have to bear with the architecture at present. We will fix this at some point. There should be a transform here. This chap. Just need to find a nice solution for this problem. But the more we add more meta types, the more we think about the problem. I forgot again about that thing. Okay, cool. Oh, of course we're gonna stuck again with the updates. So yeah, so as you can see, the biggest problem we got. One thing we did not do. We forgot to update our lists. Let's go back to our lists. Origin transform 9. Which is this guy here. Engine. I don't know why my parenthesis is not working anymore, but smart parent I think was causing trouble, so we had to disable it. Now then, if we were to simply add it here, I'm sure I'm gonna get lots of complaints in the video that this is just not a very nice way of doing it, but this is another of the reasons why I want to make these videos, because I want people to understand how the architecture works, even the warts and the problems. I think it's important to see how software development really works, because if you look at that end products, they all look nice and look, well, most of them anyway, they look polished. And what I would like to show people is that actually the in-between states are anything but. You have to go to this phase where a lot of hackery going on, a lot of hacks to just get things to work, and then you start seeing these patterns, and then once you see the pattern, then you can do something about it. You can then say, oh, this is a bit silly, we shouldn't really be doing this every day, so come up with a solution that handles the use cases. But it's important not to try to come up with a solution before you collect the patterns, because you may end up creating solutions for problems that don't actually need a solution. Right, so if I now look at the JQ over this, again, leave it a few seconds, and now if you look for ABC, lovely, we can now see that our meta type is coming through all the way up to generation. So let's see how much time we still have left. Oh, 35 minutes. I think what we'll probably do is we'll call this call time on this video, because what we've done on this video is we quite neatly resolved all the problems of transporting the meta type all the way from the injection across the whole pipeline of assets and all the way into generation. And now generation is going to be something else really. So I think it kind of makes it a nice place to stop. So what we'll do is we'll just basically commit all of this. And this time around, I think, because all the work was actually just related to this particular task, we would just add that too. What we can say here is we can say assets handle new Visual Studio component meta type across a pipe transform pipeline. I don't like making commits such large titles, but so process, I guess. Process Visual Studio components. Process Visual Studio components across the transform pipeline. Okay. And that is more or less it for this video. So just to summarize what we achieved, we've now made sure that the pipeline, so let me just give you a bit of context from the beginning, because I think it's a bit confusing. So when you start reading some stuff in Dogen, you are in a raw format of some kind, so something like dia or JSON. And that's injection space, and for that we have injectors. So if I was to just open up one of these chaps here, in injection space we have these models here, whose sole job is to convert from an existing type over to our injection model. This chap here is responsible for converting from the dia type, and we have an equivalent model that converts from JSON type. And they convert to our injection representation, which is very, very simple. It's a very, very simple meta model. From the injection representation, we then move over to the assets representation, which is where all the rich meta types start to exist. This is the guy that knows about all sort of the clever meta types, and he knows about all the transforms and processing. And by the time we're finished with the meta type, it is in really good shape in order to be projected across the spaces. And that's where you enter generation space. So at this point in time, we know that our new meta type is going from injection over to assets and is being handled correctly all the way to generation. And that's where we're going to continue next video.